Hello, hello, hello. Today we shall be developing ARDL, ARDL, right? ARDL model. And here I have three variables. They are GDP, then export, and consumption. We have these three variables, right? And here some are I1 and some maybe I0, right? But none is I2. None is I2. So I can develop ARDL model. And we can also call it as bound test. Okay. So our model actually looks, our model looks like this. Actually, it looks like this. It's coming up. So many things. Okay, I make it big. You can see better. Okay, our model actually looks like this. Okay, it looks like GDP is the dependent variable that I have taken. GDP is the dependent variable, and we have a intercept B1, B2, and we have the variable expo. What is expo? Export plus B3. Then our another variable is consumption, right? Consumption is our another variable so far. So this is our model, right? From this model I can develop the ARDL model. Okay, so first I have to select optimum number of lakhs for this model. Okay, so the optimum number of lakhs should be okay. So first I begin with the 6 lakhs, right? 6 lakhs. Then I check AIC and SIC criteria. Okay, so having 6 lakhs. Okay, so so my model having 6 lakhs will be like this. Okay, will be like this. I go to quick estimate equation, and so 6 lakhs, right? So I put it DGDP, meaning that so we take it first difference of GDP. C is the constant. So I put it properly now. GDP lakh 1, right? So make sure all things are written properly. Then lakh 2, GDP lakh 2. Okay, then D GDP lakh 3, then D GDP lakh 4, D GDP lakh 5, then D GDP lakh 6. Okay, then we start with the export. D expo that is export, right? Export lag 1, then D export lag 2, then D export lag 3, D export lag 4, then D export lag 5, then D export lag 6. Okay, so it is done. Then my third variable is consumption. So I start with the cons. What is called cons? Cons means consumption. Okay, D cons lag 1, then D cons lag 2, then D, sorry, I make it all big, D cons lag 3, then D cons, lag 4, then D cons lag 5, then D cons lag 6, right? Okay, so we have put all lag, but we have to take other three variables such as GDP lag 1, right? Then export, that is our second variable, lag 1, and the finally cons, right, lag 1. So here you can see our all variables are here. You can see from here cons, export, and GDP, right? We have these three variables are here, right, already here, and there are 350 observation in total. Okay, here what is this? What is this? These three? These three actually Longrun model. So this one I have taken here, whether these three variables have long run associationship or not. So that is why here I have taken these three variable as lag 1, and here you can see there is no first difference, no first difference, but other variables got first difference data. Okay, I check one by one slowly. DGDP, DGDP lag 1, DGDP. You must keep two bracket here. Lag 3, lag 4, lag 5, lag 6. Then export lag 1, lag 2, lag must have two bracket. X4 should have two bracket also, and it should have two bracket, not one. Okay, two bracket. Decons 2, decons 3, decons 4, two bracket, and here is also two bracket, decons also two bracket. Okay, I double check again, double check lag 1, lag 2, lag 3, lag 4, lag 5, lag 6. Export lag 1, lag 2, lag 3, lag 4, lag 5, lag 6. Decons lag 1, lag 2, lag 3, lag 4, lag 5, lag 6. Here I have done a mistake. Should have a bracket, right? Should have a first bracket. I think second, okay, there is a bracket here. Then finally, I have three variables. Okay, I think the model is set properly, having 6 lakhs. Okay, what I do, I better make a copy, right? I keep a copy. I keep a copy here, right? Okay. Okay, now I can run this model, and here GDP is the dependent variables, right? And all are independent variable, and this one we can call it as a standard ARDL model, right? Standard ARDL model having three independent variables having 6 lakhs each variable. Okay, I make a copy the whole things, right? I keep a copy like this. Okay, then I run the model, so I press OK. So the model has been estimated, right? This is my model. GDP is the dependent variable and all are independent variable, right? We can see all are independent variable. Okay, what I do, uh, uh, so what I do, the thing, I can keep it as a savings. So our model actually it looks like this. So here I paste it because this is my model, right? So I keep it. I keep it. This is my model, right? Having 6 lakh. Okay, so from here the model having 6 lakh. So what is the value of lakh selection? Akaika criteria. And what about Schwarz criteria? Having 6 lakh. Okay, so I can take a note about it. Okay, I take a note. Okay, lakh 6, right? When there's a lakh 6, how much is AIC? The AIC is the value is how much? AIC value is minus 5.98, right? From here, okay. So minus 5.98, right? And what about the second one? SIC criteria. How much is the value? So our model is where? I think she is here. She is here. Okay. SIC criteria, the value is minus 5.73. So I write it minus 5.73. Okay. So that is lakh 6. Okay. So second step, I can develop the same ARDL model having 4 lakhs. Okay. So okay, I can show you all my data. Just you show all the data here. I can show you. Just I'm showing all the data. Okay, I can show you all the data. If you want, open as a group. This is my data, right? All are here, right? 350 data. Okay. Okay. Now I shall develop the ARDL model having 4 lakhs, right? Okay, I go to quick and estimate equation, and here my models are 6 lakhs. So here I make 4 lakhs. So I delete this 2 from here, this 2 from here, and this two from here also, and I delete this one from here. Okay, this one is here. Okay, now as before, here GDP is the dependent variable, and all are independent variable having 4 lakhs, right? All are remain unchanged, right? All are remain unchanged. All are remain unchanged here, right? All are remain unchanged, right? Yeah, all are remain unchanged here. Okay, now I run this model having 4 lakhs, right? Okay, so I proceed. I think it is all right. I double check lag 1, lag 2, lag 4, lag 1, lag 2, lag 4, lag 1, lag 4. Okay, press OK. So it is my second ARDL model. You can see DGDP is the dependent variable having 4 lakhs, right? Okay, here you can see the Akaika information criteria 6.01, Schwartz information criteria minus 5.84. Okay, so what I can do, I can keep a record. I can keep a record of these two, right? So one is 6.01 and 5.84. I keep a record here. Okay, lag. Okay, now I take lag. Lag 4. So what is the value of AIC? The value of AIC has been minus 6.01, and value of SIC has been minus 5.84, right? Minus 6.01, SIC 5.84, and make sure lower the value of AIC and SIC, better the model all the time. Okay, now I take a model having 2 lakhs, right? Then we check about the value of AIC and SIC. Okay, as before, I click on the quick estimate equation. Okay, this is my model. Okay, here I take only lag 2, right? Each independent variable. So I am deleting and making it 2. Okay, I think I delete more. Export 1, export 2. I delete all these things. Okay, deleting all these things. Then come up decons 2, decons 3, decons 5. I delete all except I keep all the 3 variables, right? Which three may have long run associationship. Okay, so this is my model having 2 lakhs. Okay, I think it is fine. Set. I can click OK to run the model. Okay, so this is my model, the new model having lag 2, and DGDP is the dependent variable as before, and you can see lag 2, right? All variables have lag 2, and here as before, how much is the value of Akaike? The value of Akaike is it becomes 6.02, and value of short j become 5.91. Okay, so what I can do, I can keep a record of it. Okay, lag, when there is a lag 2, what is the value of AIC? It becomes minus 6.02, and SIC become minus 5.91. Okay. Okay, now you can see from here lag 6, lag 4, and lag 2. Okay, out of these three models, which model has lower AIC and SIC criteria? So after checking all these three models, here lag 2 has the lowest value of AIC and the lowest value of SIC, right? You see, it is the lowest and it is the lowest also. So model having lag 2 is the best model, right, out of all the three models. Okay, now we can concentrate on lag 2 model to proceed further. Okay, so our model is here already, lag 2 model. Lag 2 model is already here, right? This is my lag 2 model. You can see I have the lag 2 models. Okay. Okay, now I have to check whether this lag 2 model has serial correlation or not, and I have to check whether this model is stable or not, right? Okay, how to proceed? Okay, first I check whether this ARDL model has serial correlation or not. How to check? I go to view, then residual diagnostic, then serial correlation LM test, and here I keep lag 2, press OK, and you can see the observed R square value. So here the probability value is 6.10%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that this model has no serial correlation. So we are happy about this model. Okay, then we check whether this model is stable or not. As before, I click on the view, then stability diagnostic, then I click on the recursive estimate. Okay, then I click on the Kushum test, right? Kushum test. I press OK, and here you can see this line. This line is within this two red line. This line is within this two red line, meaning that our model is stable, right? So our model does not have any serial correlation and our model is stable. So we are happy about this model. Okay. Now we can go for bound testing, right? And we can check whether our variables have long run associationship or not. Okay, here I told you so our model looks like this, right? Sorry, how is the model? Okay, our model is like this, right? Okay, now we can check whether GDP, export and consumption all these three variables have long run associationship or not. We can check it now. And okay, now the question is that how to check it, how to test it, and we call it bound testing. Okay, here you can see this one is the model having lag 2, and this model is the best because AIC and SIC value is the smallest. Okay, in this model, this one is C1, C2, C3, C4, C5, C6, C7, C8, C9, C10. So it is C8, C9 and C10. Okay, now we can apply the world statistics, right? We can apply what? World statistics to check it. Okay, we shall apply world statistics. Okay. It is C8, C9, C10. Okay, as before, I go to view and coefficient diagnostic, and I go to world test, right? Okay, world test. So whether C8 equals C9 equals C10, sorry, C10, whether they are equal to 0 or not. So actually this one is our null hypothesis. Whether GDP lag 1, export lag 1 and consumption lag 1, whether they are 0 or not jointly. Okay, so I press OK. So I press OK now. So I press OK now to check it. Okay, so press OK already. Okay, then after that, okay, so this is the world test result, F statistics, right? Okay, how much is the F statistics, and this is the probability, right? But here, this is the here we shall take the critical value from the bound testing, or okay, here I am writing how much is the F statistics, 23.55, right? That is my F statistics. So here our F statistics, sorry, here F statistics is how much? I've done a mistake. Okay, here statistic is the value of F statistics has come up. Just 1 minute. Oh, sorry, why it is coming like that? Okay, our F statistics value, just I take it up. Okay, I take it up a little bit so that we can, okay. Okay, our F statistic value has been become 23.55, and this value should be compared with Pesaran critical value, right? Value at 5% level, right? Pesaran critical values at 5% level, and here our model is what? Our model is unrestricted intercept. Our model is unrestricted intercept, and our model has no trend, right? So now we can check the critical value when the model has unrestricted intercept and no trend. So that is our model that we have developed. Now we can take the critical value at 5% level. Okay, So from the Pesaran table, right? From the Pesaran table, our lower bound value is 3.79, and upper bound value has been 4.85, right? So we have these two value from the Pesaran table. Okay, so and what is the guideline? The guideline is when the F statistics, right, is more than upper bound value, upper bound value, right, we can reject the null hypothesis, right? Null hypothesis, right? That is the guideline. So here our F statistics is how much? You can see 23.55, right? That is our F statistics, 23.55, and this one is more than upper bound value, 4.85, right? So we can reject the null hypothesis and can accept the alternative hypothesis. Okay, what is our null hypothesis that we have set? Just a minute. Our null hypothesis that we set already here. You can see our null hypothesis is C8, C9, and C10 equal to 0 that we have just received. So we can reject this null hypothesis, meaning that C8, C9, and C10 are not 0 jointly. It means that the three variables are which are three variables such as, I'm showing again, three variables such as GDP, export, and consumption have long run associationship, right? That means all the three variables move together in the long run. Okay, so all the three variables can move together in the long run. So now we can develop the model further using short run and long run issue. We can set it properly. Okay, and now first we check what is our long run model that I showed you already last time. It looks like this. That is our original model that I showed you, this original model, and here all the three variables have long run associationship, right? Okay, now from this model I shall be taking the residual of this long run model, right? Okay, then so first I develop this model, right? This model I develop it. How? As before. How to develop it? I go to quick estimate equation. So GDP is the dependent variable, then C, then expo, then consumption. So so this model we can develop, right? So I proceed. Okay. Okay, so this one is my long run model. Okay, now here GDP is the dependent variable, export and consumption are independent variable. Now from this model I shall derive the residual of this model, right? How? You can see the residual actually already here, it has been already estimated, right? Residual of the model. So I take a copy, and I can paste it again, right? Paste it, and I give it as a name ECT, error correction term, right? Press OK. You can see one variable has been created. So this one is the error correction term. Actually this variable and this variable is the same. This variable and this variable is the same variable, right? Okay, now I can develop our model further having lag 2. Okay, how to proceed? I proceed as before. Okay, as before. So this is my model, right? No, not this one. Okay, so our best model having lag 2, that we know already. Okay, I run it again. Estimate equation D GDP, then I put C D GDP having lag 1. Okay, D GDP having lag 2, then D export having lag 1, D export having lag 2, sorry, then D consumption, right, having lag 1, then D cons having lag 2. Okay, now so this one we have already done. Okay, now I am adding one more variable, that is called ECT lag 1, right? Just I have added this variable, 1 period lag of the residual from the Longrun model. Okay, so now this is my model, so I am double checking because lag 2 is the best model. That is why I have taken it like this. I think it is fine. I take a copy if needed. Okay, I think we have done it properly. There is no problem so far. I see, so I can proceed if you allow me. Press OK. Okay, this is my model. You can see from here. Okay, so this is my dependent variable, right? Variables, and this model has lag 2. Okay, this model you can see, so these are all what? Short run coefficient, right? These are short run coefficient, and this one is the speed of adjustment. ECT is the speed of adjustment. Here it is how much? 64.94%. The speed of adjustment toward long run equilibrium is 64.94%. And here what is the guideline? It should be negative and it should be significant. It is negative and it is significant, meaning that the whole system can get back to equilibrium, long run equilibrium, at the speed of 64.94%. Okay. Okay. Now I check whether this model has serial correlation or not, whether this model has stability or not. I go to view as before, then residual diagnostic, then serial correlation, LM test, and here I take lag 2 as before. You can see F statistics, right? So we can reject the null hypothesis, meaning that this model has serial correlation. That is not desirable, right? This model has serial correlation. Okay, now we check whether this model has stability or not using Hossain test as before. I go to view, then stability diagnostic, then recursive estimate as before, then Hossain test as before. This line is within these two red line, meaning that this model is stable. So we are happy about this model. But the problem is that this model has serial correlation. We cannot accept this model. Okay. So what I should do now? Okay. So what I can do, I can delete one variable, or I can drop one variable to so that we can get a better result. Okay, what I do from our model, I delete this variable from this model, right? I delete DGDP lag 1 from this model, and other remain unchanged. Other remain unchanged. So now this is my model. Then press OK. Okay, this is my new model. You can see DGDP lag 1 is not here. Okay, in this model I check whether there is serial correlation or not. I go to view, residual diagnostic, serial correlation, LM test. I take 2. You can see we cannot reject null hypothesis, meaning that there is no serial correlation. We are happy about this model. Okay, then we check whether this model is stable or not. I click on the view, then stability diagnostic, then recursive estimates, Hossain test, press OK. You can see this line is within these two standard deviation, right? Within this two red line, meaning that our model is stable. So our model, this model is stable. We are happy about this model, right? Because no serial correlation and the model is stable. Okay. Now from here we can check speed of adjustment, and also the short-run causality. From here we can check. Okay, so first I talk about short-run causality from export, right? Okay, it is C1, C2, C3, C4, right? C3, C4, right? C3, C4, and it is C5, C6, C7. Okay, so first I check C3 and C4, right? So what I do, I click on the view, then coefficient diagnostic, wall test, C3 equal to C4. We are doing wall test. It is our null hypothesis. C3 C4 is 0 or not. I click on the OK. Wall test. It is our null hypothesis. They are 0. We cannot reject null hypothesis, meaning that we accept null hypothesis, meaning that they are 0, meaning that export lag 1, export lag 2 jointly cannot cause GDP. So we call it short-run causality, meaning that there is no short-run causality running from export to GDP. Okay, now we check one more, whether these two consumption lag 1 and lag 2, C1, C2, C3, C4, C5, C6, right? C5 and C6, I do it as before. Diagnostic wall test, C5 equal to C6 equal to 0, right? This is my null hypothesis. Press OK. This is the null hypothesis. We cannot reject null hypothesis. We accept null hypothesis, meaning that they are 0. That means there is no short-run causality running from consumption lag 1 and consumption lag 2 to our dependent variable, which is GDP, right? Okay, so here in our model there is no short-run causality from the independent variable to dependent variable. Now we can check the speed of adjustment, that is ECT, and the coefficient is 75.62%. It is negative and also significant because probability is less than 5%. As a result, we can say speed of adjustment towards long run equilibrium, or we can say other way, this whole system is getting adjusted at the speed of 75.62% towards long run equilibrium. Okay, I can write this one if you ask me. Okay, I can write it this one this way. I can write it. The system is getting adjusted towards long run equilibrium at the speed of 75.62%. So that is the outcome, right, of this ARDL model having lag 2. So model having lag 2 is the best model because it has no serial correlation. The model is stable, and also the model is getting to long run equilibrium at the speed of 75.62%. Only problem, no, not problem, in this model there is no short run causality running from independent variable to dependent variable. I think we are done. Thank you very much for being with me for a while.